Okay, hello everyone. So we're in the data analysis session 2. So in this session, we'll still be using the StatCrunch to do the data analysis of generating statistical tables and charts. Okay. And as for the data we're using, you can locate that in our Canvas website in the week 2 module. Under part 3, you can see our PowerPoint has been uploaded here, and this is the corresponding data set you should be using. Okay, so make sure you download this data set and open that, import that into the StatCrunch once you log into the Pearson MyStatLab. So go to MyStatLab and hit StatCrunch on the left, and also hit StatCrunch website, and you should be opening this page as we did last time. So go ahead and enter, import the data from, so go ahead and load the data from file, okay. And go ahead and try to drag your file here. Once you have downloaded, you may have that session 2 data in your download folder. So go ahead and click that too. All right, and just enter upload. Then these are going to be the variable we'll be using. Okay, so let me first of all clear my annotation. Okay, these are the variables, including the number of elections, age of women, gender, beers, reaction time, candidate, treatment, severity for our lesson today. Okay. All right, first of all, going back to our PowerPoint, we'll be looking at the corresponding graphical methods for one variable. Okay, so if you have only one variable, what we can do for the graphical representation as charts and tables, what we can do. The first example we're looking at is when it comes to the variable that is discrete, okay, discrete random variable in terms of distribution. So let's look at this example 1. It says, consider the scenario of an exit poll on election day. We're interested in the number of elections out of the last 4 in which the individual participant participated. So this is going to be the corresponding variable, right? It is the number of elections out of the last 4 years in which, out of the last 4 in which the individual participated. And we have a sample of 20 voters, and these are the corresponding number of data, which is certain people participate only in 1 election, certain people participate in 4 elections all. Okay. And we're going to construct a frequency distribution and histogram for this data set. Okay, so frequency distribution and histogram is what we did in our session 1. You guys should still remember. So go to the data, and then you should go to histogram, right? Stat. Go to tables, frequency. We're looking at the elections, so move the number of elections to the right, and by default, frequency and a relative frequency is enough. If you do want to have more of the output, you can also collect the other ones. Cumulative frequency and cumulative percent, cumulative relative frequency, those are also the ones that we can choose and compute. So here is going to be the chart that you are able to paste, right? Remember, copy and paste, and copy your graph and paste into the Word file for any of the homework when we're doing. All right, so that's going to be the output for the frequency distribution table, which tells us there are 10 people out of the sample of 20 that participated in 3 elections in the past with a relative frequency of 50%. This 0.5 is just 50%, right? And there's only 10% of the people get surveyed did all 4 elections out of the 4. All right, so that's frequency distribution. And then similarly, you're able to, okay, you can just close this, then it will go to the StatCrunch over here as one of the results you've done. And we can also produce the second one, which is histogram. Okay, so in terms of histogram, just need to go the graph and go ahead, click histogram, and choose this variable number of elections, and we're doing the frequency. Okay, if you are putting frequency on the right vertical axis, go ahead and choose this one. You may also elect to use, sometimes people want to see the percentage. You can also click relative frequency if that's what you're interested in. And then compute, right? So this will be the histogram, which tells again, you can see 10 people. So 10 people have done election of 3 elections, right? 10 people participating in 3 elections in the past. Okay. So those are the 2 charts we're able to produce when it comes to one variable, right? That's what we got. Okay, here is the frequency distribution table. And here is the histogram with a bunch of bars showing the frequencies. Okay. The distribution is shown below in the graphical form called a histogram. It shows the same information as you see in the frequency distribution table. However, it also shows the shape, right? You can see the shape is going up, okay, frequency increasing, and then drops down to 1, okay, drops at when there are 4 elections participated, okay. All right, next we're going to look at distributions with many possible values. This is for continuous variable, okay. Continuous random variable. Okay. The example we're using here is age of a sample of women who were prescribed hormone replacement therapy. So these are the specific data. Okay, there are a lot of data, right, compared to just 10 or 20. And it wouldn't make sense for us to list them just one by one. So for those cases, we need to construct a grouped frequency distribution, putting them into different categories, okay, with the starting category starting at 35 and a width of 5 for each category. So let's go ahead and do this. All you need to do is go back to the StatCrunch, okay, go to the session 2, and this time find the correct variable, that's the age of women, right, who were prescribed hormone therapy. Okay, by the way, I need to close this. And we're going to go into histogram. So graph histogram, age of women who were prescribed hormone therapy. We're doing frequency, but this time we also need to make sure you are doing the bin. So bin has starting and widths, right? So we can just enter what we need to have starting at 35, widths of 5. Let me double check that's consistent with what we have. Actually, 35 and widths 5, correct. So 35 and 5 and compute. So you're able to see this is going to be the corresponding histogram. Close my annotation. And for this histogram, it has 1, 2, 3, 4, 5, 6 categories as was indicated, right? That was required. Okay, for 6 of the bars. And if you simply click each bar, it will tell you which lines, okay, which particular data values are in this bar. Also click this one, right? Okay, and so when you click these 2 bars, we have chosen 13 rows as indicated here. Okay, let me also simply clear what we have chosen. All right, this is the histogram. If you want to see the corresponding frequency distribution table, you can also do that by doing the tables and frequency and choose age of women, and then go ahead and do 35 starting data and a width of 5. Okay, and that will also tell you specifically how many women in each category, right? Age of women. For example, 50 to 55, there were 6 women in that particular category. Okay, so all the results will go back to the upper left corner. So this is our histogram that we have obtained. We're able to describe the shape in the next chapter when we talk about this. All right, next is qualitative variable. Oh, excuse me, qualitative, no, not quantitative. This should be qualitative. Or categorical data. For qualitative or categorical data, we described they are the ones that you're able to put the values into different categories, right? For those ones, we have to use a bar chart. Okay, bar chart, it's not called histogram. It's called bar chart for qualitative variable. All right, we're gonna look at a bar chart that we can generate for variable gender. So go to gender, session 2, and there's a column variable called gender, and we're gonna go get the graph. And bar chart is under the bar plot. So with data, okay, choose gender, right? And we don't have to do any grouping here. And go ahead and hit compute, and that will give us this bar chart, not histogram. You can tell in this bar chart there are 21, right, as shown here, frequency 21. So 21 female and 19 male, okay, in this particular sample. So get back there. Over next, we'll be looking at the graphical methods for 2 variables. Okay. When it comes to 2 variables, both of variables can be quantitative, right? Let's see, suppose 2 people measure their reaction time after having increasing amounts of alcohol. They want to know if there is a relationship between the alcohol consumption and the corresponding reaction time. Excuse me, yeah, my drawing isn't very flat. Reaction time is measured by a machine that rings a bell and also clocks the amount of time it takes the person to move his or her hand from one button to another. They collect the data given on the right. Okay, we're using those 2 columns. Beer, how many? Yeah, is it 2 or 1 or 4, right? Maybe measured by using bottles. Okay, so particular unit of measurement, and the corresponding reaction time, okay, being recorded. So for us to do this, what we can do is we're able to construct a scatter plot. That is the most straightforward way for us to see the relationship between these 2 variables, beers and reaction time. So go to your StatCrunch, and we're using beers and reaction time, these 2 columns, right? All right, and we'll go graph scatter plot. So scatter plot will be under the graph and a scatter plot right here. Okay. Well, it is the beer that will determine the reaction time. So X variable will be independent, how many beers they've had. Y variable will be the corresponding reaction time as dependent variable. Okay. And for here, that's all we need to go and compute. And that will give us the corresponding chart, as we can see here, right? This is the beers versus the reaction time. So it does look like there is a certain relationship between these 2. But anyway, you can again copy your graph or save your graph and embed it into any of your Word file, right? Okay. So that's our scatter plot. We can see there is a sort of a best fitting line pattern here that will be going up. Okay, so it'll be somehow over here. Yeah, which means as the amount of beers increase, right? Beers going up, and the reaction time would go up as well. So more drinking, more reaction time, which is very consistent with our common sense. Okay, so that scatter plot is when you have 2 quantitative variables. But what if you have qualitative variables, right? They're not able to be described by using particular data. Even if you put that at 1 and 2, it's not very meaningful of comparing 1 with 2. So let's see. We'll examine relationship between qualitative variables. For qualitative variables, the primary tool we use is called Contingency Table, or certain book call that as cross tabulation. For example, suppose we want to know if there is a relationship between a person's gender, which is going to be qualitative, and the person's preference of 2 candidates, right? Data for 25 data for certain people is given to the right, and you can see that here in our section 2 data as well. Let me close this. So we're looking at the gender versus the preference for a candidate. Okay. And then we're going to construct by using these two, by using these two, we're going to construct a contingency table. Okay. Or so-called cross tabulation. So what we need to do is we're going to go stat and we're going to go contingency table. Hold on, where is it? Let's see. Yes, it's under the stat. It should be the table, contingency table. Go ahead and click contingency with data. Okay. So now, it depends on how would you like to arrange the table. You can put the gender in the row, right? So I have one row for female, one more for male. That's the gender. Okay, in row. Hold on. And then the column variable will be the corresponding candidate they would be preferred. Okay. And let's go ahead and compute over here. So this is going to be the most basic table you're able to generate, contingency table, right? Which only tells you the frequencies. Okay, so there's female who would prefer candidate number 1. There are 11 of those. You can also tell there are 8 people, right? So 8 male who would prefer candidate number 2. It does tell you rows is gender and columns is candidate. So these are genders and these are candidate they would prefer. Okay, so that's the basic one for the table. We can also list some other information such as row percentage here. Okay, so in that table that we had, oopsie, I should have not closed that table. Contingency table, so I can still retrieve that table here. Sorry, not this one. It should be this one, contingency table. Yes, you can go options and then edit your setting, still on the gender and the rows and candidate for the columns. And suppose you want to know the row percentage, go ahead and choose row percentage, compute, and it will give you this table now. Okay. In this table, guys, you can tell is rows are still gender, column still the candidate they would prefer. This one tells you what's the corresponding format in each cell. Okay, so 11 will be the count and 52.39 will be the corresponding row percentage, right? Okay, so in each row, what's the percentage? So if we look at this output, we can tell female who would prefer candidate number 1, there is 52.38% of the female who would prefer candidate 1. Okay. In terms of the second one here, it tells you 47.62% of female would prefer candidate 2. And if you add these two percentage up, you should be getting 100%, which means all the females has been taken consideration. All right. And similarly, you can do the argument for the males for the 2 rows. All right, so that's the row percentage. We've included our summary here, right? Okay. Also, we can say 57.89% of male would prefer candidate 1 and 42.11% of male would prefer candidate 2. Okay. If you adjust that table again, the output again, to turn that into a column percentage, that's also okay. Okay, you'll be getting a contingency table with the column percentage there listed. Okay, and we can interpret those results as well, right? And this time there are column percentage, so each of the columns should add up to be 100%. That means out of all the voters who would prefer candidate 1, 50% are female and 50% are male. In the second column, it seems out of all the voters who would prefer candidate 2, 100%, 44.44% are male and 55.56% are female. All right, so that's it. We can also construct 2 cluster bar graphs. Okay, this would be done in in the StatCrunch as well. Let me close this one here. And that will be about the graph. They're still about qualitative, so it'll be a bar plot, okay, and a with data. And we are doing 2 bars where we're doing the gender and also their candidate preference. So choose 2. Okay. The first one, we can say gender based on, right? If you want to know the gender based on which candidate they have picked. So grouped by candidate. And as for the grouping options, we can do split bars, and it will construct something like this. Okay. So you can see the gender, right? The gender, we can see there are, okay, let's see what's frequency. There are 11 female who picked candidate 1. Let me clear. And then we also have 10 female who would prefer candidate 2. Okay, so that's the gender for a bar chart. Similarly, you can do the bar chart for the candidate preference. Okay. So all you need to do is, again, bar plot with data, and then this time will be candidate as the columns, and then grouped by gender this time. And you'll be getting a different bar chart. Okay, these are so-called a cluster bar chart. Candidate 1, okay, out of all the person who picked candidate 1, we are having 11 of those are female, 11 of those are male. Out of all the person who picked candidate 2, we have 10 of those are female and 8 of those are male. Okay. And the one on the left is better for us to comparison choice of candidate within gender, right? Each gender, you can see what's going to be the difference of their choice. Okay, next one is if we want to compare qualitative variable with quantitative variable. Okay, example we're using is people who suffer from migraine are randomly assigned to take a drug or a simple placebo, which means it's not an actual drug. They then rate the severity of their symptoms. Higher number means more severe symptoms. We want to compare the placebo group to the medication group. This is a way of looking at the relationship between the treatment group and a severity group, right? And treatment could be into different categories, and severities are different values. We can construct a side-by-side box plot for these 2 variables. Okay. Go to your StatCrunch and you go to graph, and then it's called box plot. So box plot, find box plot here. And we are comparing their severity based on their treatment, right? Okay. So we're going to go compare severity, which is based on different treatment they have received. Okay, and compute. In this case, we can tell on the right, okay, on the vertical axis, it's the severity, and in the bottom is the corresponding treatment group, because of medication versus the other group of the simple placebo. Okay, placebo does have higher severity in general than the group that receives the actual medication, the actual drug. Okay. Yeah, so this side-by-side box plot provides insight into how the groups compare. Obviously, as we described, the medication group does have lower severity. Okay, so that's the method we are going to use in our chapter 2, and I hope you guys can use these same of the tools to work on the homework problem. Okay, and keep in mind all of your results are in here. You can always retrieve them. Okay, and let me know if you have any questions. Thank you.